our Goody's rule. So for this we need to substitute value of m as 4. So again I will have to use equation star. So after substituting we will get integration from x0 to x4 y dx equals to 4h into y0 plus 2 delta y0 plus 5 upon 3 delta square y0 plus 2 upon 3 delta cube y0 plus up to so on. So now as we had converted in terms of p, here also we will convert I, that is integration in terms of p. So integral will be from 0 to 4 y dx equals to h into integral 0 to 4 y0 plus 2 delta y0 is nothing but p delta y0 plus p into p minus 1 upon 2 delta square y0 plus p into p minus 1 p minus 2 upon 6 delta cube y0 plus p into p minus 1 into p minus 2 into p minus 3 upon 24 into delta is to 4 y0 plus up to so on dt. So integration is with respect to p. So after taking integration, h constant as it is. So y0 and y0 is constant. So integration y0 is y0 p over 0 to 4. Then again this will become p square by 2 delta y0. So now integration of p square minus p by 2, this will yield us, it will be p cube upon 6 minus p square upon 4 delta square y0 plus up to so on. Okay, so that will be your integration, and after this, so it is from 0 to 4, and after substituting the values from 0 to 4, you will get h constant 4 y0 plus delta y0 8 plus 20 upon 3 delta square y0 plus 8 upon 3 delta cube y0 plus 4 delta raised to 4 y0, which is equal to h into 4 y0 plus 8 delta y0 plus 20 upon 3 delta square y0 plus 14 upon 45 delta raised to 4 y0. It is 14 upon 45. So now solving this, you get, you have y0 which is nothing but h into 4 y0 plus 8 delta y0 is y1 minus y0 plus 20 upon 3, it is y2 minus 2 y1 plus y0 plus 8 upon 3 y3 minus 3 y2 plus 3 y1 minus y0 plus 14 upon 45 y4 minus 4 y3 plus 6 y2 minus 4 y1 plus y0. So after solving and taking y0, y1, y2, y3, y4 common, you will get h into y0 into 4 minus 8 plus 20 upon 3 minus 8 upon 3 plus 14 upon 35 plus y1 into 8 minus 40 upon 3 plus 8 minus 56 upon 45 plus y2 into 20 upon 3 minus 8 plus 14 upon 45 plus y3 into 8 upon 3 minus 56 upon 45 plus y4 into 14 upon 45. So the final answer is 14 upon 45h into y0 plus 32 upon 7y1 plus 12 upon 7y2 plus 32 upon 7y3 plus y4. Okay, so this is the value. So after solving this, you will get, taking 7 common, you'll get 2h upon 45 into 7y0 plus 32y1 plus 12y2 plus 32y3 plus 7y4. So that's your Boole's rule, and you can directly have the formula for the error in Boole's rule as minus 8h raised to 7 945 y x bar. So second derivative of x bar, so highest value of x. So now next is Whittle's rule. So again you have to put value of n as 6 in the equation star. So again solving this, you have integration x0 to x6 y dx equals to 3h upon 10 y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6, and the error is given as minus h upon 7 140 upon 140 second derivative of x by x bar. So now if you have few examples, so it is given that there is a solid revolution. We have another example. So it is given that a solid of revolution is formed by rotating about the x-axis and the area between the axis, the lines x0, x equals to 0 and x equals to 1, and a curve to the point with the following coordinates. The coordinates are given as x and y. So now you have to estimate the volume of the solid formed, giving the answers to 3 decimal places. So we know that volume, to calculate volume of any surface, any structure or solid, we have the formula as v equals to pi into integral 0 to 1, because it is with respect to x, the integration is with respect to x, so we need to take the extreme points of x, and we know that it is from x equals to 0 to x equals to 1. So the integration goes from 0 to 1 y square dx. Now we have the points x and y given, so we have to find y square. So calculate y square using this. So you'll get x and y square as x is 0.00 and y square will be 1.000, then 0.000. Next is 0.25. For that, value of y square is 0.9793. Value of y, that is value of y was given as 0.9896, so y square will be 0.9793. Similarly, you need to calculate for the rest of the points. So 0.5, so y square will be 0.9195. Then 0.75, you'll have 0.8261, and for 1 you'll have 0.7081. Now you need to use Simpson's 1/3 rule for h equals to 0.25. So what we have is pi into integration 0 to 1 y square dx, which is equal to 0.25 upon 3 pi into y0 plus 4 y1 plus y3 plus 2 y2 plus y4. So substituting the values, you will get pi into 0.25 upon 3 into y0 is 1 plus 4 into y1 plus y2, which is 0.9793 plus 0.8261 plus 2 into 0.9195 plus 0.7081, that is a y4. So volume after calculation you'll get it as 2.8192. Don't forget the unit, so cubic units. So now our next part is Romberg integration. So now if we consider an integration r which goes from a to b by dx, okay, so you need to evaluate it by using trapezoidal rule, okay, but the difference is previously we were using just one difference, that is difference between the point was h. It was either 0.25, 0.5 depending on the sum. But now in Romberg integration we are using two different differences between the points. So for this, if you have an interval I, so this is your interval I, then you should divide this interval into two sub-intervals. So that is I1 and I2, and for this I1 the difference between the points should be h1, and the difference between the points for this sub-interval I2 should be h2. So respective errors for this sub-interval I1 will be E1 and for I2 will be E2. Okay, so now they have directly given the formula for I1, E1 and E2. So we know that error in trapezoidal rule was -1 by 12 b minus a. Here, as it is error with respect to the first subinterval, you have to use h1 square y double dash of x bar. Similarly, it is -1 by 12 b minus a h2 square y double dash of x bar. So here again y double dash of x bar is nothing but second order derivative of y and the highest point, highest value of it at a certain point x. So as you know that this is an interval, right? So if you consider a y value, then if you take double integration, then highest value won't change for. So now even if error with respect to this subinterval I1 and error with respect to subinterval I2 is different, but value of the highest double derivative of y will be same for both the subinterval. So you can directly substitute here as y double dash of x bar equals to y double dash of x double bar. Okay, so after substituting this and taking ratio of both this equation, you will get E1 upon E2 equals to -1 upon 12 b minus a h1 square y double dash of x bar upon -1 upon 12 b minus a h2 square y double dash of x double bar, but instead of x double bar you can substitute x bar. So from this you'll get this minus half, -1 upon 12, -1 upon 12 cancels, b minus a, so you'll be left with E1 upon E2 equals to h1 square upon h2 square. So now multiplying it with -1, you'll get minus E1 upon E2 equals to minus h1 square upon h2 square, and subtracting, adding 1 to both sides, you'll get 1 minus E1 upon E2 equals to 1 minus h1 square upon h2 square. Solving this, you'll get E2 minus E1 upon E2 equals to h2 square minus h1 square upon h2 square. So after taking the reciprocal, we'll get E2 upon E2 minus E1 equals to h2 square upon h2 square minus h1 square. Now error is nothing but, see, E2 is nothing but whatever we have calculated value of I2, that is integration with respect to the second subinterval, and minus the exact solution or exact integral. Similarly, even is nothing but I1, that is integration which we have calculated using trapezoidal rule or whatever, minus the exact solution. So you'll get E2 minus E1, nothing is, you'll get this as I2 minus I1. So E2 will be H2 square upon H2 square minus H1 square as it is, into this E2 minus E1 will get transferred over here, so we'll get multiplied by I2 minus I1. So we therefore obtain a new approximation which is I3. So to get I3, that is integration with respect to with the help of I2 and I1, we have, so I3 is nothing but I2 minus E2, where I2 minus E2 is H2 square upon H2 square minus H1 square, I2 minus I1. So solving this, you will get I1 H2 square minus I2 H1 square upon H2 square minus H1 square. Okay, so this is the formula for I3, which is defined by using I1 and I2. But now if in case H1 is your H and H2 value is nothing but, which is this another difference in between the points, it is H by 2, then we can refine this formula to get I3 as I1 into H square upon 4 minus I2 into H square upon H square upon 4 minus H square, which is equal to I1 H square minus 4 I2 H square upon H square minus 4H square. So solving this, you'll get 1 upon 3, 4 I2 minus I1. So if you have two subintervals where the difference between the points vary, where one difference is h and other is h by 2, if they are related to each other, then you can directly use this formula, which is a simplified version. But if the differences between the points are different for two subintervals, then you need to use this formula. So it depends on the example which you are solving, which formula to use. So let's see one example. So if you have I, which is equal to integral 0 to 1 upon 1 plus x dx, we have to use Romberg's method. So first we have to use our previous methods, which are trapezoidal method or whatever. But if it is mentioned in the example, you have to follow that particular method, or else whichever is easy for you, you can opt for that. So here it is given that you have to use trapezoidal rule, and the differences are h equals to 0.5 and 0.25, and the next is 0.125. So first you need to calculate I1, I2, I3. So I1 is with respect to integration with respect to the difference 0.25. So I1 is nothing but integration with respect to 0.5, and which was 0.7084. We have already solved this example particularly by trapezoidal method. So in exam you need to solve this. I am directly solving this here. So I of 0.25 is nothing but 0.6970, and I of 0.125 is nothing but 0.6941. So you have previously solved this, so you can refer that solution. And now the main part is by Romberg integration. It is very simple, it's easy. So see, it's easy by graphical method. So if you consider 0.7084, then 0.6970, and the last one is 0.6941, right? So first we have, this is I1, This is your I2 and this is your I3. So now if you consider I1, I2, I3, then to find the next part, you have to consider the pair of these two. So first you'll consider I1 and I2. So for this, you have to use this formula, which is this. Okay, so as the difference is constant between the two respective sub intervals, you can directly use this formula, that is 1 upon 3 4 I2, which is 0.6970 minus I1 0.7084, and this leaves us, we got its value as 0.6932. Okay, so similarly here you need to calculate value of this. So let it consider I5. So if this is, then I2 takes place of I1 and I3 let it be as I2. So after solving this, you will get 0.6931. Now as we got these two integers, again we can use the same formula to calculate the next integral, that is 0.6931. So this is diagrammatic representation of whatever we are solving. So let's see how stepwise we can solve.